Welcome to the 15th session of galvanic cells, which comes under electrochemistry. In this session, we will be dealing with corrosion of metals. And this is the first session of corrosion of metals. It will be followed by the second session, that is the corrosion of metals part 2. Okay. Now, we all know corrosion is actually the destruction of a metal, in which the metal gets converted to another compound, and this compound, there are two chances. The compound may stick firmly to the surface of the metal, and then such corrosion is not that destructive, because this protects the metal to be corroded. So, it prevents the metal for being corroding. Now, otherwise, if the surface which gets corroded, it peels off and then the fresh metal surface is exposed, the extent of corrosion will be very high. So, in this session, we will be dealing with corrosion and how the corrosion can be controlled, and also we will be seeing the theories. Okay. So, first we will be seeing corrosion and what are the causes of corrosion and types of corrosions. Okay. And types of corrosion mainly based on the chemistry of corrosion. Okay. Now, we will go for the definition. Corrosion is a chemical destruction of a metal. Metal is getting destroyed as a result of a electrochemical reaction. It is an electrochemical reaction where there will be an oxidation and reduction processes with gases and moisture present in the environment. So, it is a chemical destruction of a metal due to certain electrochemical reactions in the presence of gases and moisture in the environment. For example, let us see some examples with a picture. First one is the rusting of iron. You can see that the metal get rusted. This is the unrusted iron substance, and at the top you can see the brown patches. They are the rust formed on the iron metal surface. So, the two metals, the first one is not corroded, the other one is a corroded one. Now, here is a picture of nails. It is all corroded. You can see that certain parts are not corroded, but almost most of the portions are corroded. Another example is tarnishing of silver. The first picture shows the untarnished silver spoon. The other one, which is the blackened one, it is the tarnished silver. Again, here I am showing the picture of tarnished copper. The first one is a pure one, it is a new one with a nice copper shining appearance. This is partially tarnished. The other one with the bluish green color is heavily tarnished copper. This is heavily tarnished to a greater extent. Okay. So, these are the examples. There is corrosion can be, some of the example is rust on iron, tarnishing of silver, tarnishing of copper. Now, what are the conditions that cause corrosion? First is exposure of metal to moisture or water containing salts. It can be either moisture in the atmospheric air, or it can be water containing salts. For example, the most corrosion occurring is under seawater, because we know that seawater is a very good electrolyte. So, in the presence of that also the metal gets corroded. Then exposure of metals to air containing gases like carbon dioxide, sulfur dioxide, H2S, etc. These gases are capable of converting the metal into their compounds. Okay. High temperature, that is another cause, and high temperature, greater the higher temperature, the rate of corrosion is very high. Then another one is the acidic condition. Most of the acidic conditions, they increase the rate of corrosion in metals. Now, we will go for the classification of corrosion, and remember we are on the basis of the chemical deterioration taking place of the metal. There are many classification for corrosions in the view of engineers view, and here we are mainly focused on the chemical deterioration of metal, how it is getting deteriorated chemically. Based on that, we have the classification. First one is the direct chemical corrosion, or it is also known as dry corrosion. Second one is electrochemical corrosion or wet corrosion. From the name itself, it is clear that there is some aqueous layer or any liquids involved along with that. So, it is known as electrochemical corrosion or wet corrosion. So, we will move on to the direct chemical corrosion or dry corrosion. Direct chemical corrosion or dry corrosion is the action of the metal with gases like it can be either oxygen, carbon dioxide, hydrogen sulfide, etc. in the absence of moisture. It should not be wet at all, water should not be present. So, in the absence of moisture, and therefore, it is known as dry corrosion. There the gases present in the atmosphere, they interact with the metal and form certain compounds which leads to the corrosion of the metal. So, again they are classified as oxidation corrosion, as the name specifies, it is the corrosion with oxygen gases. Second one is corrosion due to gases other than oxygen, and the third one is liquid metal corrosion. So, these are of two types: oxidation corrosion, corrosion due to gases other than oxygen, and the third one is the liquid metal corrosion. So, we will see one by one in detail. First one is the oxidation corrosion. Oxidation corrosion occurs by direct action of oxygen at low or high temperatures on the metal, and of course, it is in the absence of moisture. Most of the metals except noble metals, they undergo oxidation corrosion, especially at high temperatures, and even some metals, if they are active, they undergo oxidation corrosion even at the room temperature. The reaction is so, like metal combines with oxygen to form the corresponding metal oxide, where N represents the valency of the metal. For example, if I have to write the corrosion of aluminum, aluminum, the valency is 3, and therefore, we will put it as 3/2 oxygen, and since oxygen we require valency of oxygen is 2, and the product should be Al2, that is a valency of oxygen, and here that will be Al2O3. So, N, this is N, right, and this is also N. N represents the valency of the metal, where the valency of aluminum is equal to 3. Okay. In a similar way, even the alkali and alkaline earth metals, they also undergo oxidation even to the room temperature. You can see that is sodium, which has got a silvery white color shining appearance. Due to the action of oxygen, its surface gets dulled. Okay. So, any metal can undergo this type of oxidation corrosion. Now, here there is a picture of corroded aluminum. Okay. You can see the raised paths on an aluminum sheet. This is due to the formation of aluminum oxide, where aluminum combines with oxygen of the air and gets corroded as aluminum oxide. Okay. The chemical reaction is shown as 2Al plus 3/2 O2 gives Al2O3, and this is the corroded aluminum. Now, here in the case of aluminum, it has got a benefit that this aluminum oxide formed on the top of the surface of that metal, it acts as a protective layer. It adheres strongly to the aluminum metal surface, and it protects aluminum from further corroding, and therefore, it forms a protective coating. And in such cases, aluminum when undergoes corrosion, as long as the top layer we do not remove it, the rest of the aluminum is safe, it remains uncorroded. Okay. That is what is said here. Aluminum oxide forms a thin protective coating over aluminum metal surface, which prevents the metal from further corroding. So, it is acting as a protective layer. Okay. Next is corrosion due to other gases, like except oxygen. There are gases like direct combination of it can be either halogens, hydrogen sulfide, sulfur dioxide, carbon dioxide, sulfur trioxide, nitrogen, etc., with a metal surface. The extent of corrosion depends upon the chemical affinity of the metal with the gas. Greater the chemical affinity of a particular gas with the metal, greater will be the corrosion. Okay. If the protective layer on the metal, it forms a protective layer, the corrosion can be prevented further. If it does not stick firmly to the metal surface, otherwise you can say that it peels off, or if it is volatilizing off, if the compound forms is volatilizing off, all these conditions expose the fresh metal surface, which is again susceptible for corrosion. Now, let us see some of the examples. First one is tarnishing of silver. You have seen silver anklets, even silver vessels, lamps, etc. After some time, if you do not clean it daily, there will be a blackish coating forming on the silver, and this is what we call the tarnishing of silver. And silver, when exposed to sulfur or sulfur compounds, mainly it is hydrogen sulfide from atmosphere, gets converted to black silver sulfide. The reaction is silver combines with hydrogen sulfide to give Ag2S. This is the corroded silver, silver sulfide and hydrogen. Okay. Now, this tarnished silver, you can remove that. How? By you can rub with some abrasive material, so that the silver sulfide form is removed from the surface. Okay. Or you can treat it with aluminum. When we treat with aluminum, what happens is, aluminum being more reactive than silver, it takes up the sulfide ions from silver, and silver is left free. The reaction goes on like this, that is Ag2S combines with aluminum to form metallic silver, and aluminum gets converted into aluminum sulfide. Now, here when we use abrasive methods to clear the surface, we lose some amount of silver, which has been converted as sulfide, while this method is converting silver sulfide back to silver, and therefore, there is no loss of metal in this method. So, this is a better method to remove the tarnish on the silver. Next is corrosion of silver with chlorine gas. Silver has got a great tendency to combine with chlorine to form silver chloride. Okay. So, silver reacts with chlorine to form silver chloride. Okay. Now, this silver chloride has got an advantage. This also forms a protective coating on the surface of the silver metal, and silver chloride, as you all know, it is white in color. So, there is no much noted difference between the corroded part and the uncorroded silver. Next is corrosion of tin metals with chlorine gas. Here, tin metal combines with chlorine to form stannic chloride, that is tin with a valency of 4, stannic chloride. Now, this tin chloride, that is tin 4 chloride, is highly volatile, and therefore, what happens is the compound stannic chloride volatilizes from the surface of the metal, leaving a fresh metal surface, which is again exposed for further attack by chlorine, or it is getting further corroded. Okay. That is what. if we have a protective coating, the metal is saved, otherwise the metal is again prone for more and more of corrosion. Next is liquid metal corrosion. It is a new type of corrosion. Here it has been seen that when liquid metals flows over another metal, what happens is these metals, they either dissolve in the solvent metal or they get into the interstitial spaces of the solid metal. Okay, so, liquid metal corrosion occurs due to the action of flowing liquid metal at, usually it is occurs at high temperatures, on another solid metal or an alloy. So, when a liquid metal flows over another metal surface, it can be pure metal or alloy, there occurs a corrosion. This corrosion is known as liquid metal corrosion. During liquid metal corrosion, what happens is the liquid metal either dissolve in the solid metal, they dissolve in the solid metal or penetrate into the solid metal. Now, what happens when these two occur? The crystal lattices, that is metal is in the form of a crystal lattice. When something penetrates in, the strong bonding is lost, okay, and therefore, what happens? There will be a weakening of that solid metal, okay, either dissolving or penetrating into. And this type of corrosion is mainly found in nuclear power plants, where they are using liquid metals. Okay. Now, this is an example of steel getting embrittlement of steel, and here you can see that the steel object, you can see there is a crack occurring, there are several cracks occurring in between. This is because it is actually due to liquid zinc, or it can be either lithium. When it flows over it, it penetrates and causes, that is, the metal become weak, the metal surface shows cracks because the bond between the metals are broken. Okay. So, it forms cracks, and such corrosion is also observed, that is embrittlement. Embrittlement means the metal is made brittle. Even aluminum and its alloys by zinc and mercury, it can be liquid zinc and mercury, it can cause the same thing on aluminum. Then again embrittlement of copper and its alloys by liquid lithium and mercury. So, these are the examples for liquid metal corrosion. Next, the next one is the electrochemical corrosion or the wet corrosion. Electrochemical corrosion or wet corrosion occurs only in the presence of moisture, remember that. Here electrochemical corrosion of metals occurs when electrons from atoms at the surface of a metal are transferred to a suitable electron acceptor region through a medium which is capable of transporting ions. So, there are three factors. One is the metal should have a surface where it can transfer its electrons to another region through a medium which is capable of transporting its ions to. Now, where there is a transport of electron from some region, that means there is a removal of electron from that region. So, that region can act as an anode, and there should be another region where these electrons are transported and these electrons are being consumed, and that region will be acting as the cathode. So, in electrochemical corrosion or wet corrosion, there will be an anodic region as well as a cathodic reaction taking place, and we have an anode region and a cathode region. Okay. And we know that metals are conducting and they can easily transport the electrons. Okay. So, there is anodic and cathodic areas present, and there will be a conducting medium. What is that for? For transport of ions. Now, the electrons set free at the anode flow through the metal and are consumed in the cathodic region, and as a result corrosion always occurs at the anodic area. Where the metal is getting disrupted is at the anodic area. You can see this picture. This is the corrosion of iron, in which this is the anodic area where iron is getting oxidized. It gives its electron and it moves through the metal to the cathodic area. At cathodic area, it forms the corresponding, that is, the electrons are consumed and corresponding compounds are formed. Now, here is where the metal is getting corroded, the anodic area. That is what, just to show that I have included this picture, and you can see that there should be moisture, that is, the water droplets are shown here to show the presence of moisture. Okay. Now, the driving force is the potential between the anodic and cathodic sides. If the potential difference is very high, the rusting takes place at an extremely high speed. Okay. If the anodic and cathodic sides, the potential difference is not that much, the electron moves very slowly and the rusting occurs very slowly. Greater the potential difference, greater will be the tendency of corrosion. The first step involved in corrosion is actually the oxidation of the metal. If you prevent this step, you can prevent the corrosion. So, first step is oxidation of the metal, and only on this the electrons are released, which can be taken up by another region where it is ready to accept the electrons. Okay. So, such corrosion can occur when a conducting liquid is in contact with the metal, or when another metal or an alloy is dipped partially along with the metal in the solution. So, there should be a conducting liquid, and with the same metal itself it can form a cathodic region, or with some other metal or alloy dipped in the same solution where we have the metal. So, all these conditions, they allow the corrosion of the metal. So, in this session we have been seeing what is corrosion and how the metals are being converted into certain compounds, and thus the metal is getting destroyed. And we have been seeing the causes of corrosion, and the main culprit is moisture and also some acids, temperatures, etc. Then we have been seeing the types of corrosions based on the chemical deterioration which the metal undergoes, and in that we have direct chemical corrosion or dry corrosion, that is one. Then in that it is further classified as oxidation corrosion, that is only with action of oxygen, and corrosion due to gases other than oxygen like chlorine, carbon dioxide, hydrogen sulfide, etc. Liquid metal corrosion, that is when we have the liquid metal getting into the interstitial spaces, or they dissolve in that solid metal, and such corrosions are known as liquid metal corrosion. And we have been seeing electrochemical or wet corrosion, in which we have an anodic region and a cathodic region. From anodic region, the electron has to be transported to the cathodic region, and also there should be an electrolytic solution to facilitate these reactions. And that is all for this session. Thank you.